In this video, we're going to do a summary of torque and inertia formulas that you have to know for Unit 5 and 6 of AP Physics. So let's start off with our rotational kinematics formulas. So you have omega initial plus T theta initial plus omega initial T plus 1/2 T squared. Omega squared is equal to omega plus 2a alpha theta. Also, you need to know your linear rotational formulas. V is equal to r omega. Acceleration tangential is equal to lever arm times alpha. AC is equal to r omega squared. Now for torque, we have, so this is torque. We have torque is equal to RF Now we also have Newton's second law. Say it like Newton's second law. Rotational torque is equal to alpha, using your rotational equivalence. Now, rolling without slipping, you have A is equal to R alpha, V is equal to R omega. Now, for our moment of inertias, we have 1/12 ml squared, rod about center, rod about end is 1/3 ml squared. Actually, for hoop, we have mr squared. For solid cylinder, we have and then for a special cylinder, which is the one we use in question 8. Now for parallel axis theorem, md squared. Now for rotational kinetic energy, now for angular momentum, this is for a rigid body. Now for a particle, now conservation of angular momentum, this is when you have no external torque. About your pivot, so some algebra moves that you have to remember that combine these ideas is that when you have torque and linear, it's usually going to look something like this. You have your mg sine theta minus your ff ma, then you have rff is equal to inertia alpha A is equal to R alpha, and then you solve. So you have to remember that what you can do is, you know that alpha is equal to A over R, and then you substitute this thing in. And you use friction. Instead of friction, you use torque. Now for energy conservation. It's usually something like something along the lines of that. You will just do, then you solve for omega. And then you use for angular momentum. You also need to know when to substitute rolling condition. And remember, you have to be able to use, every time you have back here to parallel axis theorem, there's usually going to be a lot of like fraction combination. That's when you have like 1 over 12 plus 1 over 16. That's 4 over 48 plus 3 over 48. Because you know that you can get a common factor of 48, which is multiplying by 3 up here and then here. That's by 4. Now for collisions, what you have is an energy equation. You have angular momentum equation that you have to solve, and then you do this simultaneously to get a quadratic.